Hey guys, so what we're going to do today is I'm going to make you a little video and tell you about some stuff in the book that I would normally teach you in class, but we don't have class, so this is how we're going to do it. So if you want to open your book with me, we're going to be on page C36. So I'm going to kind of walk you through what you've been doing already, and we're just going to kind of look at it together, kind of like we're in class. So if you look at page C36, that's where we're going to start. So what you need to know for this, you need to know that fossils are found in sedimentary rock. If you remember back to last year, sedimentary rock is when it layers on top of each other. So that makes sense for fossils because they would layer on top of another one. If you look on this one, they can form other ways too. So that's where we have trace fossils, molds, and casts. So if you look at the bottom of the page, it says the bones of this dinosaur were buried in a layer of sedimentary rock, and the fossil shell they show you is below that. So that tells us that the deeper it is, the older it is. The newer stuff's going to be on top. Wood, bones, teeth, shells, they can become fossils. Footprints, droppings, wormholes can become fossils. Those are called trace fossils because it's something they've left behind. It's not something that is something solid we can look at. Let's see. They give clues on what the animal ate. So if we look at the droppings, we can look at what they ate and we can learn more about that type of animal. If we look at the tracks, we can look at the shape of their feet. We can see maybe how big or small they were, things like that. That page has some good pictures of the different trace fossils as well. If you turn over other types of fossils, you need to know the difference between a mold and a cast. A mold is an imprint made by the outside of a dead plant or animal. A mold forms when water slowly washes away animal or plant remains out of rock. The space that's left is the mold. So think about a mold like something that you get at the craft store that you put clay in or something like that. That's a mold. It has the outside of it. When sediment fills that mold, that's when you get a cast. Then it says we have chemical and physical changes. Heat and pressure can destroy it. So sometimes the fossils do get destroyed by heat and pressure. Sometimes what's left is a black film. It's called a carbon film. And that is what we look at on this page where it has the picture. I think it's a fern, sorry. The fern has what's left in black. That would be what a carbon film looks like. Sometimes they become petrified fossils. That's at the bottom of this page. Petrified means that minerals slowly took the place of what was once living with the fossils. When you think of petrified, usually you think of trees and wood. Another one is the amber. If you've ever seen Jurassic Park, that's the good example for this one. At the bottom, it has this dragonfly stuck in sap, and it becomes something called amber. In Jurassic Park, they had something like that. I think it was a mosquito or something. And that is how they brought them back to life. That's the fossil. That one, you can see more of the whole thing. You can see the soft parts and the hard parts because it gets hardened really quickly. Tar pits, glaciers, those can trap big animals. So long time ago, woolly mammoths roamed around the world. They were related to elephants. They got stuck in tar pits or in glaciers, and that's how they survived. Well, they didn't survive. Their fossils survived for us to be able to see. La Brea tar pits in Los Angeles, California. They have saber-toothed tigers, which are now extinct. Horses, elephants, birds, deer, all kinds of things. So those things get caught up in it. Okay, so if you turn over, let's look at lesson 2. This is on C42. So this is basically how scientists look at these fossils to study about things we have now. So it says fossils are like snapshots of the past. They're preserved evidence of how long dead living things may have looked. Fossils evidence can show us how living things have changed over time. So the first one they give you is an Archaeopteryx. Archaeopteryx. That one is similar to birds and chickens. If you look at the bottom, it shows you the chicken skeleton versus the Archaeopteryx. They're very, very similar. So that tells us that those two are very similar and probably related. Then you have the elephant-looking one at the bottom. If you look on, let me see what page that one is. That one might be on the next, no, yeah, next page. Gomphotherium. That's called a Gomphotherium, and it looks a lot like mammoths that lived a long time ago and elephants we have today. The ginkgo tree is another one they showed you. That one has not changed. When we look at ginkgo trees today versus the fossils, they look the exact same. Some things change, some things don't change, but that's why we have to study fossils so that we can see what changes. Okay, if we turn the page, the importance of fossils, like I just said, that tells us what Earth was like a long time ago. When we study these things, we can see how they're related to animals we have today. So they give you on page C44 dinosaur fossils, and at the top, it's showing you how they dig it up. If you look at the picture, they have little ropes and things tied off. When you're digging up fossils, you have to be super, super careful, because if you let somebody in and they get onto the area where you're digging and they get into it where they're not supposed to be, they can destroy the bones and things like that. So look at page C44. Scientists can infer from fossils how an animal moved. Fossil footprints can show us how they walk. The bones can show us how they walk, whether they're big bones or short or long. On the other page, the mold can show us the soft part, so we can say if it had skin, fur, feathers, scales. We can look at how they might have looked, which is what they do for dinosaurs, because no one was around to see them. All right, if you turn the page, this is how they actually uncover the fossils. So once the bone is discovered, they take pictures of it first. Then they make a map of it so they can find out exactly where it was. There might be others near it. Then they carefully remove it from the home. Hammers and chisels break away the large pieces of rock. Then they use little tiny pieces like dental drills and things like that. So once they get it out, they put this special chemical on it. It's a hardener. So what it does is it prevents the bones from crumbling. Then they pack it in foam or plaster and take it to a laboratory. So they don't actually study it where they find it. They take it to a laboratory where they have their tools. Preserving fossils. So once it gets to the lab, that's when they take it apart and they really start to clean off little pieces at a time to look at it. When they get all of the rock and things off of it, they make it into a mold. So they make a mold of it to be able to study it better without actually handling the fossil at all times. Okay, if you turn the page, the ages of rocks and fossils. Scientists study rocks and fossils to find out how old the fossils are. So they form in layers, and if you look at this picture of the dinosaur, you're going to see that again. Scientists uncover many fossils as they examine and find the age of rock layers. The fossils on these pages show the diversity of living things during Earth's past. So what happens is a dinosaur would die, and right here he's covered in water. Over time, things build up on top of it, and the heat and pressure crushes it down. When it crushes it down, it gets kind of packed into these layers. So what happens is one day somebody discovers it, and then they start to dig around, and that's how they uncover the fossils. So what I need you guys to know is that the deeper the fossil is, the older it is. The ones that are higher above the layers, those are going to be newer. All right, if you turn over to C52, this is a big one. Normally in class, we would spend a couple days on this. So fossil fuels are what we use to put gas in our car, heat our homes, things like that. Fossil fuels are the remains of once living organisms. So what I want you to look at on this one is something called petrochemicals. Those are things made from oil. So petrochemicals are used in medicine, makeup, paints, plastics, and these fossil fuels come from organisms that lived a long time ago that are now buried in our earth. So look at energy from the sun. This is what I need you guys to know too for your test. Burning fossil fuels releases energy that originally came from the sun. The energy was stored in the bodies of ancient organisms that were buried in sediments millions of years ago. So coal, natural gas, and oil are found in layers of sedimentary rocks. Remember, sedimentary layers. So when the dinosaurs or whatever organism we're talking about ate their food, they're getting the energy from the sun. When the sun comes down, that's how the plants make their food. So when the plants make their food, they're getting energy from the sun. Whatever eats that food is getting energy from the plant, which got their energy from the sun. So the energy that we're using now originally came from the sun. It's just being passed through these fossils. Petroleum is what we use to put gas in our car, things like that. Natural gas is something people use in their homes to heat or to cook with. You need to know that we're running out of fossil fuels. Fossil fuels are non-renewable resources, which means they take millions of years to form. So if we're using them all up, they're not going to be around forever. That's why people have electric energy stations. That's why people are all about using electric cars, things like that. If you turn over the formation of coal, you need to know this. Much of the coal we use today comes from plants that lived in swamps millions of years ago. As the plants died, they sank to the bottom of the swamps. Mud and other sediments slowly covered the remains. Over many years, the dead plants were buried deeper and deeper. Slowly, great pressure and microorganisms changed the remains into coal. So same thing as we were talking with fossil fuels. Coal is formed from a lot of pressure. So if you look at the picture at the top, that would be millions of years ago. The plants died, they go to the bottom of the forest and they decay. Soon other things come and it layers and layers and layers, it packs it down. So when it packs it down, it turns it into coal, which when we dig up in coal mines so that we can have energy. There are 4 types of coal. You need to know those. You need to know what they are from least carbon to most carbon. So the one that has the least is called peat. The next is lignite. The next is bituminous coal. And the next is anthracite. So peat is kind of crumbly. It looks a lot like just a dirt clod. It's mined by digging at Earth's surface. It has a lot of water, so they have to dry it really well before it can be burned. Lignite is the brown coal. It's crumbly and has a little bit more carbon. It's not as good of a fuel though because it doesn't have as much carbon. Bituminous coal is the most useful type of coal. It burns at high temperatures. We use it in fuel in factories and electric power stations. It has more carbon, less water. Anthracite is a hard black form of coal, and you can see it's kind of shiny too, whereas bituminous coal has little streaks and layers in it. It burns very hot with little smoke or ash, so that's something you want. When you burn it, you don't want it to have a whole lot of smoke and ash coming from this. So it is rare and a valuable energy source, so the most likely to be used is bituminous coal. If you turn the page, this one I didn't put a lot of this on your work for yesterday, but I do want to go over it with you. Petroleum and natural gas are found only in sedimentary rock. Almost 60% of the world's supply is in sandstone. The rest is in limestone and other porous rocks. Geologists can identify rock structures that are likely to hold petroleum and natural gas so they know where to look for these resources. Since the microorganisms that formed them lived in seas, many petroleum and natural gas deposits are found underwater. Underwater drilling takes place from huge platforms built over the water. In the United States, these platforms are located in the Gulf of Mexico and off the California coast. Some deposits of petroleum and natural gas are under land in places that were once shallow seas. Drilling for these deposits occurs in California, Texas, Alaska, and other states. When a drill locates a deposit of petroleum or natural gas, the petroleum has to be pumped from the ground. Natural gas comes out by itself. If there is not enough petroleum in one area to be pumped out directly, hot water or steam is forced into the deposit through a nearby well. This forces the petroleum, which is less dense than water, to the surface. Sometimes the petroleum is under such great pressure that it gushes to the surface. Gushers, as they are called, waste a lot of valuable petroleum. Modern wells are capped to keep this from happening. So if people go into this as a profession, they usually live on boats that are in the Gulf of Mexico, off the coast, and things like that. where they pump this from the earth and from under the water all day long. It is a dangerous job, but you can make a lot of money doing it. So that's how they get all of this from the earth. They drill really, really deep, and they use something to kind of pump it out. So what I want to do now is go over what's going to be on your test next week with you. You need to know your vocabulary. You have mold, cast, fossils, trace fossils, fossil fuel, natural gas, peat, lignite, bituminous coal, anthracite, and petroleum on it. Go over the study guide I made you last night and make sure you can know those in a question form. So a tree buried in a mineral hot spring would form a petrified fossil. So think of trees when you think of petrified fossils. That's when the minerals fill in the hollow spaces of the wood and it becomes a fossilized tree. You need to know that a footprint is a trace fossil. You need to know that bones would be the most likely, that's my dog, I'm sorry. Yeah, bones would be most likely to form a fossil. You need to know that by studying the droppings, we can find out what the animal ate. You need to know that the rock layers at the bottom are the oldest. You need to know that a mold forms when the remains of dead plants or animals are washed out by rock and water. You need to know that heat and pressure may destroy most of the buried remains of a plant or animal, leaving a thin covering called a carbon film. Remember the black carbon. You need to know that when minerals take the place of once living materials, petrified fossils are formed, so like we said with the tree. You need to know that anthracite is the type of coal that contains the most carbon and burns the hottest. Remember, it's rare. Let's see what else. We study fossils to see what Earth was like. Fossils are found in sedimentary rock because it layers on top of each other. And then we talked about why the energy we use today comes from the sun. It's because when the animal ate the plants, it got its energy from the sun. You need to know, we went over this with our testing review, that, sorry, my dog is being weird. So if you have a fish or a seashell fossil found in the desert, it tells us that it was once underwater. So if you guys have any questions, let me know. I'll try to get a Zoom lesson going with you guys next week. So if you have any questions, you can hop on and ask me.